This section introduces substitution, the method that reverses the chain rule. We will learn to identify an inside function, match its derivative, and turn a complicated integral into a familiar one. It is mathematical detective work. Unmask the inside function and suddenly the case becomes much easier to solve. These objectives focus on recognizing structure, carrying out the substitution correctly, and checking the result. Choosing U is the main strategic decision. The rest is often routine. It is like choosing a major. Choose wisely and you are destined for success. Choose poorly and your youth will be wasted. Composite expressions often signal that direct integration rules are not enough. We look for an inside function and its derivative because that is the fingerprint left by the chain rule. Calculus leaves clues everywhere, and a good detective will notice them at a glance. The chain rule differentiates a composition by multiplying by the derivative of the inside function. Substitution reverses that process by packaging the inside function as U. The expression x squared plus 5 is the inside function, and its derivative 2x is already present. After substitution, the integral is simply u to the fourth. A simple name change and suddenly everything falls in place. Differentiating the answer reproduces the original integrand exactly. This is the most reliable way to check an indefinite integral. Do the check if you have extra time in the test and care for perfect grades. These 5 steps organize every substitution problem. The crucial requirement is that the whole integral must be rewritten in U before integration begins. Mixing x and u is like submitting half the assignment in French and half in Morse code. After substitution, only u and du should remain. If an x survives, the change of variable has not been completed. Variables are like in-laws. Mixing the old one with the new one usually creates unnecessary drama. The derivative of 5x minus 2 is 5, and that factor appears exactly in the integral. We then apply the power rule to u to the 1/2. Everything matches so neatly that it feels suspiciously unlike test material. The derivative of the inside function is 2x, but only x appears. Solving for x dx introduces a factor of 1/2. Missing constants are manageable, unlike missing homework, which could be emotional meltdown. A linear inside function always contributes its slope when differentiated. Dividing by compensates for that factor. It is a small mathematical service charge, but at least this one is clearly disclosed. The expression e to the x plus 4 is a natural choice for you, and its derivative e to the x is already present. The complicated integral becomes a basic power rule problem. It is like discovering the terrifying final exam is actually open book. When the numerator is the derivative of the denominator, substitution produces 1 over u and therefore a logarithm. A perfect numerator/denominator group project arrangement. The derivative of the denominator is 4x, so the numerator differs only by a constant factor. The inside expression is always positive, allowing us to omit absolute values. Positivity has privileges, even in calculus. Choosing u equal to the natural logarithm works because 1 over x dx is exactly its differential. The resulting integral is just the power rule. The logarithm brought its own derivative along, which is more preparation than some students bring to class. We rewrite the denominator as a negative power and choose its inside expression as u. The derivative matches after a factor of 1/3. Negative exponents are not bad attitudes. The power rule still works like a charm. A good substitution simplifies the integral because the derivative of the chosen inside function is present. Computing du immediately tests the choice. It is like checking the bus number before boarding, a tiny effort that prevents a very long detour. An inside expression is useful only when its derivative can be matched. If the derivative is missing as a variable factor, a constant adjustment cannot fix it. This substitution has potential but no support, rather like a study plan created at midnight. We first integrate the derivative using substitution, but we keep the constant c because the initial condition has not yet been used. The initial condition selects one function from the whole family of antiderivatives. Substituting x equals 0 gives c equals 3. The initial condition is the calculus equivalent of assigned seating. Suddenly there is only one correct place to be. Integration recovers a total quantity from its rate of change, while an initial value determines the constant. Units provide a useful check on the result. Units are the quiet students of mathematics. They rarely interrupt, but they notice every mistake. The rate is negative, so the production cost is decreasing. Substitution with u equal to 2t plus 3 gives the general cost function. A decreasing cost is the kind of negative result every company places proudly in a positive presentation. The initial cost determines k, and evaluating the model at t equals 6 gives $5.40 per unit. The production cost drops substantially, which makes the shareholders smile. The total number sold is found by integrating the monthly sales rate. The exponential term requires the linear substitution factor. The product may be new, but the calculus already knows its complete sales trajectory. No devices have been sold at the instant of release, so the initial condition determines C. Evaluating at 12 months gives the first year total. 13,000 sales is impressive. What is this device? I am curious. Integrating the exponential rate introduces a factor of 1 over 0.04. The current population then determines the constant. Substituting 10 into the population model gives about 8,074 people. The numerical answer should always be interpreted in context and with units. The model gives a rate of revenue growth and an initial revenue. The linear exponent suggests substitution, and the initial value will identify the constant. Online advertising knows exactly how to follow us. Fortunately, this exponent is equally easy to track. Three years after the beginning of 2023 corresponds to t equals 3. Evaluating the model predicts about $30.39 billion in annual revenue. Apparently, the constant of integration also clicked Accept all cookies. This checklist summarizes the most common errors: an incomplete differential, mixed variables, missing constants, and forgotten absolute values or plus C. Most substitution mistakes are bookkeeping mistakes. Calculus is difficult enough without losing points because the paperwork wandered off. These formulas summarize the main substitution patterns for powers, exponentials, and logarithms. Each one depends on matching the derivative of the inside function. They are different outfits worn by the same chain rule, which apparently has a larger wardrobe than most teachers. The central strategic question is whether an inside function and its derivative can be matched. Verification by differentiation then confirms the answer. Substitution turns a complicated-looking integral into a familiar one by renaming the inside function and matching its derivative. The method rewards calm pattern recognition. When mathematics becomes intimidating, sometimes the first step is simply to call it U and de-escalate the situation.